Good morning, class. I'm Echika Nancy, by name, your maths teacher. Today, we are looking at applications of circle theorems. We are going to use the theorems that we have already in our notebooks to solve some problems. Let me remind you, some of the theorems include angle at the center of a circle is twice the angle at the circumference. We have in a circle, a semicircle, there is a right angle in a semicircle. We have another one that in a circle, the point of contact from the radius of the radius to any tangent line is perpendicular. That is, we have a 90 degrees angle. So in a circle, a semicircle, from what I said before, semicircle, there is a right angle. That is, we have just one right angle in a semicircle. In a circle, angle at the center is twice angle at the circumference. What does it mean? If I have angle at the circumference as x, in the center here, this corresponding angle becomes 2x. So it is twice the angle at the circumference. This angle here, if I have it as y, we call this angle what? A reflex angle. It is out of the triangle we have here. This reflex angle y is corresponding to this angle here at the circumference. This circumference here becomes y over 2. I hope you understand. Because the angle at the center is twice the angle at the circumference, meaning that the angle at the circumference is half the angle at the center. So with all this reminder, we can solve some problems. So take some examples. On the board, I have example 1. Example 1 says, calculate the angle marked x in the diagram. From the diagram, you can see where x is. Now, looking at the diagram, what theory comes to your mind? Theorem that says that from the center, the radius from the center in contact with the tangent, this is a tangent line touches a point at the center, at the circle. So this tangent line and this radius is a right angle. That is, I have angle 90 degrees. Angle 90 degrees. So what does it mean? That at the center here, what angle can you see at the center is angle 90 degrees. I hope I'm clear. This 90 degrees, this radius and this radius, they are the same. What type of triangle do you have? From triangle OPQ, triangle OPQ is what? A right angle. It's an isosceles triangle. It's an isosceles triangle with right angled at O. Isosceles triangle says that the two sides is equal. We have two equal sides, meaning that the angle at the base, angle at P and angle at Q, meaning that angle at P is equal to angle at Q. For isosceles triangle, the base angles, they are the same. So I can call here angle P and also call here angle P. I can call here angle Q and also call here angle Q. So if angle at the center here is 90 degrees, I have 90 degrees plus angle P plus angle Q is equal to what? 180 degree. Why is it 180 degree? Sum of angle in a triangle, sum of angles in a triangle is equal to 180 degree. Note that we have said that P is equal to Q, so I can simply write angle P plus angle P is equal to 180. So I have 90 degrees. P plus P is 2P. collect like terms. Collect like terms. Collection of like terms, we are going to leave this term with P. Then we'll take the 90 degrees over to 180 degrees. Plus 90 degrees move over to the other side of the equation, becomes minus 90. So 2P is equal to 180 minus 90 is 90 degrees. Therefore, P is equal to 90 divided by the coefficient of P, which is 2. So I have it as 45 degrees. So we'll come back to the diagram. It means that the angle at P here is 45 degrees. The angle of Q here is also 45 degrees. So we can find X. Therefore, X is equal to, remember that the total angle here, from triangle OPT, angle at P is equal to 90. Observe, angle P is 90, that is 45 plus X. 45 plus X, therefore, X is equal to 90 minus 45. So X is equal to 90 degrees minus 45 degrees, which is equal to 45 degrees. That's example 1. Example 2. P, Q, R, and X are points on a circle. If POR, angle at O, is equal to 130 degrees, calculate angle PQR, that is angle at Q. This is the diagram. We have calculate angle PQR, so I have PQR. So we are looking for angle X. From the diagram, what comes to your mind? Angle at the center of a circle is twice the angle at the circumference. Angle at the center of the circle is twice the angle at the circumference. Now, POR is equal to 130 degrees. POR is opposite the angle we are looking for. So for you to get this angle X, we have to know this angle POR, the reflex. For we to get angle X, we have to know the reflex angle POR. So POR reflex is equal to angle 360 degrees minus 130 degrees. You ask me how? Because I have sum of angle at a point. Sum of angle at a point is equal to 360 degrees. That is, the whole angle at this center is 360 degrees. So to get the reflex, I'll subtract 130 from 360 degrees, which will give us 230 degrees. So the reflex angle POR is 230. So with this, we can obtain angle X. How do we get angle X? With this, angle X is equal to angle POR reflex divided by 2. So I have 230 degrees divided by 2, angle at the center doubles the circumference. So 230 divided by 2 will give us 115 degrees. So angle X is 115 degrees. Remember that solving problems on circle theorems As you solve, you write the reasons. So the reasons is part of the solution. And I believe with this, we can apply the circle theorems to solving any problems involving circle. Then see you again in our next class.